Hello and welcome to Thursday's edition of Cracking the Cryptic. I hope you and your families and friends are managing to stay well and sane through this strange period we're living through. We're continuing to try and, I suppose, make it a little bit easier by doing two videos a day. Mark will be back later on, I think, with a puzzle today rather than a Sudoku. We've chosen a puzzle by Freddie Hand, one of the UK's best puzzle solvers, so do check that out later on tonight, UK time. Now I'm going to be having a look at this colourful offering. This sounds absolutely remarkable to me. This is called Self Killer by Peter C Hayward, and the way it works is that we have to sort of build our own killer Sudoku using the circled numbers. So let me read the rules and you'll see what I mean. So the rules are: normal Sudoku rules apply. Additionally, there are 10 coloured areas. In each, the two circled digits form a 2-digit number. The sum of all digits in an area sums to that number. Numbers do not repeat within a coloured area. So, and let's look at this one for example. So say we put a 1 and an 8 in there. This would be 18, would be the 2-digit number, and then these 6 pink cells or purple cells, you know I'm colourblind, I don't know, would have to add up to 18. So that is a very interesting mechanic. I've not seen anything quite like this before. Well, I mean, Christoph Seeliger's killer Sudoku with no numbers is about as close as it comes to this, but build your own killer Sudoku, that is... I'm very, very interested to try this. Do have a go yourselves. You just click on the link under the video. And with that, I'm going to have a go. So let's get cracking. And how do we start this? I guess some of the areas are... Yeah, I mean, we've got 2 3-cell areas here. So they can't possibly be more than a 2 in the tens digit. So this has got to be a 1 or a 2 in both of these cases. And no, actually that can't be a 2, because if it's a 2, in order to make the 3 cells together add to 20, these 2 squares would have to sum up to at least 18, and that's impossible because I can't repeat the 9, and in any case 20 would be impossible. In fact, any 2-digit sum that ends in 0 is impossible because I can't put 0 in the grid. So this has to be a 1, I think. The same must be true there. So that means there's a 1 in one of these 3 squares, or circles. One of these 3 circles. Now, I'm just wondering, can that be a 3? It can obviously be a 1 or a 2 in the tens digit, but can this number be a 30 number? So if this... I don't think it can. I mean, if we pick 31, for example, here, the problem is that I've had to use a 3 and a 1 already, so I've got far too many to make with those 3 squares. Those 3 squares would have to add up to 27. Oh, and that's actually fascinating, because look what happens as we increase that. If I make that not 1, if I make that 32, although I'm increasing the units digit, but I'm making the sum of the remaining 3 cells the same. I've still got to make these 3 add up to 27. So if I make that a 4, 34, these 3 still have to add up to 27, because 34 minus 3 plus minus 3 minus 4 is still 27. So all of that is telling me that 3 is not possible here. This has to be a 1 or a 2. So all 5-cell cages must not have a 3 in the tens position. So there's another one there, look. Here we've got a 4-cell cage. So that must be a 1 or a 2. Surely I can get to, yeah, I can get to 20 with these 3 digits on their own. So I think 1 or 2 is fine there. This one, oh bother, look, I should have looked at this earlier. So this yellow area here is 9 cells large. That means it's got to contain all of the numbers from 1 to 9. If we add up all the numbers from 1 to 9, we get 45. What's going on with my mouse there? 4, 5. So that ought to be very helpful. Oh, it's almost very helpful. So we've now got a 4 and a 5 here. So where do we put the numbers 4 and 5 in row 4 of the grid look? We can't repeat them in the yellow cells. So these cells can't be the numbers 4 and 5. Annoyingly, there's 3 positions though possible there. Closer than this. That's an 8 cell cage, look. So that's got to be a very big digit, because even if I miss out a 9 from these 8 cells, they would still sum to 36. So that has to be, that's got to be 3 or 4. In fact, why don't we just focus on 4 in this box? Where does 4 go? 4 can't go in the yellow squares. It can't go in these 2 squares because they're in the column. So the 4 must be in one of those 2 positions. Oh, that's beautiful. Look, now I've locked a 4 into the blue area. So in terms of this box at the bottom, where can the 4 go? It can't go down this side. It can't go in any of the blue squares. And these 4s I've pencil marked remove that as a possibility. So it has to go in that cell. Now, can we go further than that? I don't think that we can. We've got another big region here though. That's a 7 cell region. But the problem is you can make 7 cells equal only 28. So that's probably 2, 3 or 4 therefore. We've got a 6 cell region here, so we can't make 6 cells add up to less than 21 because 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. So this has to be a 2 or a 3. Can't be a 4 because you can't make 6 cells add up to 40 anything. 9 plus 8 plus 7 plus 6 plus 5 plus 4 is only 39. So maybe it's this row. I feel like this 45 is important. 7. Oh, of course. Oh, that's very, very nice. Look at this. Look at the 3 cell cage here. Let's think about the units digit. I've got to put in this. In fact, it might be easier if I look at this one. These 2 will work the same way. What's this digit? Let's make it, I don't know, let's make it 8. What is the effect of that? Well, it means the sum is 18. If I make this a 7, the sum is 17. So whatever I include in the units digit, this digit is contributing the units digit to the sum. It doesn't matter what it is. It's always, you know, just dealing with. So the 16 means, with this being a 6, these 2 have to add up to 10. If this is an 8, this is 18 now. These 2 have to add up to 10. That is lovely. So in fact, it doesn't matter what goes in the unit cell. It doesn't matter for what the outside cells have to sum to. That is weird. Why didn't I see that straight away? That is... So this has to be a 9 and this has to be a 9. So this is the same as this point over here, isn't it? This... Yeah, it is. It's the same point. It's the same point. So once I remove the units digit from the sum, I know that the remainder of the cage has to sum to 10, 20, 30 or 40. That is weird. It's obvious once you see it, but it's... Oh, that's very, very interesting. So, goodness me. Oh, I'll tell you what this 9 does though. That 9 fixes this row. I've got to put 4 and a 5 in the row. I can't put them in the yellow squares. These two squares must be 4 and 5. And can we go further than that? Yes. Look, in the 45 box, I've got to put a 9. Now this 9 rules out all of those. So there must be a 9 in one of those two cells. And the other digit that's going to appear in these two cells, look, is going to be whatever I put in this cell. If this is a 1 or a 2, it's going to get transported down into these two cells because it won't appear anywhere in the yellow cage. So these two squares here are 1, 2 and 9 in some order, and there's definitely a 9 in one of them. Now, what could we do next? Maybe this cage, because... So whatever I put in this square... Yeah, this can never be a 2. This can never be a 2, because if it's a 24 or 25 total, these two squares have got to be too large. They've always got to add up to 18. So this has to be a 1. And therefore these three squares have to sum up to 10. Ah, the 1 actually fixes that. Look, that fixes the 2 and the 1 there, though. Oh, this must be deliberate as well, because now, look, if these three have to add up to 10, these two have to sum up to 9. Now, they can't be 1, 8, they can't be 2, 7, and the 4, 5 pair means they can't be 4, 5. There's only one more way of making 9 in two cells. That's 3 and 6. That fixes that one to 2. So we now know, before we even look at this cell, that these 5 cells here have got to sum up to 20. Isn't that bizarre? The 1 here means this is a 1, 9 pair. So 1, look, must be in one of these 3 cells. I think I'll pencil mark that in. These 3 squares here have got to be 7, 8 and 9 to complete the box. Ah, look at this. The blue squares here, they start with a 1. So now we know whatever we put in this square, these 4 squares here have got to sum up to 10. This is so. I just want to show you again because it's just so cool. If this is 17, this digit here takes care of the 7. So you always get left with the 10 sum in the remaining 4 squares. So if we know that 4 squares have to add up to 10 without repeating a digit, they have to be 1, 2, 3 and 4, and there's a 2 there. So that's got to be a 2, that's got to be a 4, that's got to be a 3. The 4 here is the reason that we shift the 4 up to that square. We still don't know what this one is, but that's still pretty marvellous, isn't it? The 4 here disambiguates the 5 and the 4. And can we go further? There must be a 1 down there. Oh, look, I've got 1, 2 and 3 in this column. I've got 1, 2 and 3 in this column. So these 3 squares must be 1, 2 and 3 in some order. The blue one, sorry, not the blue, gosh, the purple one here, the purple 2, sees that square because it's in the same cage. So that can't be a 2. And this one can't be a 3 because a 5 cell total must be a 10 or a 20 number. Oh, now look, we can do some arithmetic on this box as well. Yes, we can, because whatever I put in this cell, I know that these 4 cells have got to sum up to 20. So I've got 20 plus 1 plus 4 plus 3. That's 28. So I know these 2 cells have got to sum up to 45 minus 28. Well, that's 17. There's only one way of making 17 in 2 cells, if you can't repeat a digit, and that is 8 and 9. So this is 28 or 29. This is an 8 or a 9. Okay, now can we go further than that? I'm sure we can, I'm just not quite seeing how. So these 3 squares have got to be 5, 6 and 7. I'll use that notation. This one can't be a 6. That one can't be a 5. Oh, and that one can't be a 5, because if it's a 5, I have to put a 5 in one of those 3 squares, and I already know those 3 squares are 1, 2, and 3. So that can't be a 5, that has to be a 7. Now there's a 5 down here, I'll pencil it in. There's a 6 in one of those 3 squares. Then look, and if we look at this column, there's definitely a 7 in one of those 2 squares, so this one can't be a 7. Okay. Now maybe this row, because we've got 6 digits in it, we need 3, 6 and 8 to take that further, so I'm not really seeing anything jump out at me as a result of that. Let's just check. No, I'm not. What am I missing here? What am I missing? Yes. This is quite a cool trick. So let's look at the blue region, which is 8 cells large. So we now know for certain that this can't be 44, because if it's 44, obviously the only way of writing 44 will be like that, and that will repeat the 4 in the row. So if it can't be 44, then we absolutely know for certain that the 8 cells have got to include a 1, because the only way of them, if they don't include a 1, that would make the sum 44, and we know all digits apart from 1 digit, which we're trying to identify, are included. So if this is not 44 and it has to include a 1, where does the 1 go? It's got to be in one of those 2 cells, because it can't, this one and these ones rule out the rest of it. And this one can't be a 1, because if this is a 1, oh, that's so clever, it's just beautiful. If this square is a 1, we try 31 here, that's just nonsense, because if these 8 cells sum to 31, there must be a missing digit, which is 14. And obviously 14 is much greater than a single digit, so that's just completely not going to work. But if this is 41, which is more credible, what is the missing digit from the 8 cell region? Well, 45 minus 41 is 4, but we've included the 4 here to make it 41. So that doesn't work. So this cannot be a 1. Oh, let's remove that one from there. This is the 1. Therefore, that's a 1 and that's a 9. The 9 can't be here now. So then, bobbins. I thought that might get us more. Oh, now look. This can't be 36, because if I make that 36, that cell has no value. So if it can't be 36, there must be a 9 in this region. Where does that go? Can't go here, can't go here. Must go in one of those two cells. Can we do better than that? No, we probably can. I can't quite see how to. 9s here and here, though, mean that that cell must be a 9. So that cage in the end totaled 19 up there. That fixes this 8 look, and that 9. That 8 is very nice. It gives us an 8 here. That makes a 7 and a 9 there. This 2 means that can't be a 2. So now let's look at this again. This now can't be 38 or 39, which means there's also a 6 and a 7 in the blue region. It's not quite, it's close, but I don't think I can do much with that. We've been blessed with some incredible puzzles on this channel recently. This is again just it's an original masterpiece. Let's fill in these cells to make ourselves feel like we're making progress. That's got to be 6, 7 and 9. So those ones over there have got to be 4, 5 and 8. Um, 20. Oh, hang on. Now, if this does begin with a 4, it now can't be 41, so it would have to be 42. No, that doesn't work. It can't be 42. If that's 42, I've got to miss two numbers out of this box, and those two numbers have to themselves sum up to 3, 45 minus 42. Well, the only way of doing that would be if I missed out the numbers 1 and 2 from this coloured region, and I've already just put 2 into it. So 42 isn't just not possible. That has to be a 3. That fixes the 3 and the 6. So that places a 3 in one of those positions, look. Now, can we do better than that? This 3 sees that square. That forces that to be a 4. And it can't be 41. So this... or 43. So this has to be 42. That's the only option left. Which means this blue region does not have a 3 in it. So down here there is no 3 in these blue squares. Good grief. I feel like I'm getting a bit overwhelmed with all the colours here. 2. So now there must be a 2 in one of these cells. Let's just check this row. Look, we need 2, 7 and an 8. With that not being able to be a 2. That can't be a 2 either because of the 2 there, so the 2 must be in this square. So this one's summed to 12. There must be a 2 in this T shape at the bottom. This one maybe then. So whatever we put in this is irrelevant. I need to make these 5 cells add up to 20. actually, no, I'm going to come back to this row. I've got a lot of information here. I can place a 4 here. These two squares have got to be 5 and 8, I think, to complete that row. 5, 8, 4. So if this is 34, this purple region is missing 11 cells, 2 cells summing to 11 that are not 3, 8 or 4, 7. So this is missing either 2, 9, and we've put a 2 in here, so we know there's a 2 in here. So it's not missing 2, 9, it must be missing 5 and 6. Now that might be interesting. And actually, look, where do we now know there's a 1 in this purple region, and that can only go there. So this is not a 1. That means that square is a 3, look. I feel like I'm missing something here. What is it that I'm missing? Well, one thing actually is, where does a 4 go in box 9? Because this 4 here means it can't go in the T region, this 4 here means it can't go in those two squares, and that 4 means it can't go there. That square is a 4. That places, yes, that must be a 4 now. Now, can we do any more with this? So 3 is now in none of those positions. So 3 must be in one of those 3 cells outside. So the cells outside the sandwich, or not outside the sandwich, but outside the cage here, are 3, 5 and 6. We now know that for sure. But annoyingly, we don't know that much about the 2, 7, 8 and 9. Let's look at this one though, because we know that these 5 cells add up to 20, and we've already got 9 there. So these two have to sum up to 11 without repeating a digit. So this can't be 7 or 9. This has to be a 6. If it's a 9, that would be a 2. If it's a 7, that would be a 4. Both of those are problematical. So that's a 6, which means this has got to be a 5. In order to make it add a 20, that disambiguates the 8 above it. Good Lord. And can we go further now? I'm sure we can. It's just ones are down here. So let's have a look at this green region at the bottom. If this is a 1, then these 4 squares have to sum up to 10. So if this is a 1, this would have to be, that would have to be a 3. And this would have to be a 2. That would be because of the 2 up here. If this is a 2, then this square, this square, this square, and this square have to add up to 20. Which means these 3 squares would have to sum up to 18. These 2 would have to sum up to 14. Now, how do we do that? Well, that might mean that that could be an 8 and this could be a 6. That might be possible. 5, 9 is impossible, so this is the only combination left. 3, 6 here, 2, 8 here. So this can't be a 1. That's got to be the 1. Oh, and that does it. Look, because now these 1s impact on this 1, 2 pair. So that fixes that in that order. This is not 2 anymore. This has to be, these squares have to be 3 and 2. You can see we've already worked out the order there. That places this as a 2, this as a 3. These 2 squares have got to be 6 and 7 now to complete the box. Good grief. Now, can we go... How do we go further? 3s. This 3 is massive. That plonks a 3 up there, look. Let's tidy up the pencil marks as a result of that. The 5-6 pair fixes the 8-5 over here. This 2 fixes the 2 as well. So this square has to be a 7 or a 9, and the 9 disambiguates it. These two squares have got to be 8 and 9, and again the 9 is powerful. 9, 8. 8 is locked into one of those squares. 9 is shifted down. We need a 7 into one of those squares as well. Sorry about that. 7, 8 there. We know that this is missing a 3, so that's a 6. That can't be a 6 now. 7, 8. That's got to be 3 or 7. That forms a 3, 7, 8 triple in that box, which makes that one a 6. Wow. Wow. This is just an incredibly original idea. 6, 7, 8 here as well. Ah, that 7, 8 is very helpful. Look. That 6 is huge as well. That's going to give me the 6 and the 7. The 8 here, the 8, 7 gets resolved. The 3, 7, the 8, the 7. My goodness. Right, so these two squares have got to be 5 and 7, I think, which again, that's resolvable. Scanning up this row, what's missing? It looks like it's a 4. These two squares have got to be 3 and 5. I don't want to make a mistake here, so I'm going to take this slowly. 3 and 5 like that, 5 and 6 like that. This square is left to be an 8. That must be a 6. I think I've filled in all the digits. Let's check. Yes, that is an absolute work of art. Yeah, very colourful work of art, and I loved that. I hope you guys enjoyed it too. Let me know in the comments. Stunning, stunning puzzle.